This lecture file relates specifically to spatial analysis within ArcMap with the tutorial manual. First, we'll look at site suitability. In this case study, we'll look at using GIS and spatial analysis to locate satellite police stations. First of all, the first step is to establish the criteria for location. And in this case, the criteria must be centrally located in each car beat within a 1/3 of a mile radius buffer of car beat centroids. They must be in retail commercial areas within 1/10 of a mile of at least one retail business. They must be within 5/100ths of a mile of major streets. So here's an example of Lake Precinct of Rochester, New York. Here we have police car beats, retail business points, and street center lines. XY centroids of the police beats. There's the 1/3 mile buffer, and here it is on the map. This is the buffer of retail businesses. And then this is the buffer of major streets. Intersect buffers can only intersect two at a time, a car beat buffer and the business buffer. The A is the car beat buffer and the streets buffer. This is the map showing possible sites for satellite police stations in car beat 251. Another option is to use multiple ring buffers. This is based on the gravity model. It comes from Newton's law of gravity. The attraction between two objects falls off by the inverse of the distance between them. The analogy in human behavior is similar. The further a potential client is from a service, the less likely he or she is to travel to use it. You can use multiple ring buffers to estimate the fall-off for attraction. And you need residence locations of clients that have a random sample in this case and data on the target population. Another case study looks at the use of public pools in Pittsburgh among youths. Officials closed half of Pittsburgh public pools during a budget crisis. This raises questions. Did the remaining pools provide good access for the city's youths? How quickly does the intended use of pools fall off with distance to the nearest pool? Owning a pool tag needed for admission to the pool indicates an intention to use a pool. Here's a map of pools and youth population. How can you tell if open pools provide good accessibility by Pittsburgh's youth? In this map, the blue pools are the open pools and the red pools are the closed pools. So the steps. 1. To build a multiple ring buffer pool. 2. Intersect buffer rings with random sample of residences of youths with pool tags and sum the youths in each ring. 3. Adjust the sum of youths with pool tags and rings to total the population size. And this is the result. Multiple ring buffers of open pools. Each distance produces a separate polygon. There's a 0.25 bright green polygon, a 0.5 light green polygon, etc. for a total of 6 polygons. If you're in the 0.25 polygon, the nearest pool is at most 0.25 miles away. Same with other polygons. So this is an interesting case study in terms of the use of multiple buffer rings and showing how it can be used to analyze a customer base or service access to a service by a population. And this concludes the lecture sections for Unit 6.